Hello, in this video I'm going to work through some examples of solving trig equations using the identity sine squared x plus cos squared x is 1. Now if you're new to solving trig equations, I'd probably recommend you go back and watch my videos on how to solve them, which I'll link below. And you can also go over to my website where it's a bit easier to navigate through all the videos I've made on lots of different topics. Okay, let's look at this first question. So we need to solve sine squared of x plus cos of x minus 1 equals 0. And we're solving this for x between 0 and 2 pi. So we're dealing in radians. So we need to make sure our calculator's in radians mode. Now the problem with solving this equation is we have a mixture of sine and cosine, which isn't really ideal. And so usually the goal when we're solving trig equations is to rewrite it so that it's just in terms of sine, cosine or tan. And so to do this, I'm going to use the trig identity sine squared of x plus cos squared of x equals 1. And what I'm going to do is subtract cos squared from both sides. And you'll see why I'm doing this in a second. So if I do that, I get sine squared of x is equal to 1 minus cos squared of x. And hopefully you can see now I can rewrite this sine squared of x in my equation with 1 minus cos squared of x, and now it's all in terms of cosine. So let's do that. So my equation is now going to become 1 minus cos squared of x plus cos of x minus 1 equals 0. And quite nicely you can see I have this plus 1 and negative 1, which are going to cancel out with each other, and so my equation just becomes minus cos squared of x plus cos of x equals 0. And this is simply just a hidden quadratic that I need to solve. So you could just factorize it now in terms of cos, but to try and make it a bit clearer, I'm going to use a substitution. Now it's not essential that you do this, but I'll do it just to make it clearer. So I'm going to say let u, so you can choose whichever letter you like. I'm going to choose the letter u. I'm going to let that equal cos of x like this. So now my original equation is minus u squared plus u equals 0. And so I'm just going to factorize this by pulling out a factor of u, and I get u multiplied by negative u plus 1 equals 0. And as I have two things multiplied together to give 0, either u equals 0 or negative u plus 1 equals 0. So I get u equals 0 or negative u plus 1 equals 0. And let's just rewrite the equation on the right as u equals 1 by adding this across to the other side. So remember, we're not solving to find out what u is equal to, we want to find out what x is. So I'm now going to undo this substitution by replacing the u back with cos of x. So we've now got cos of x equals 0 or cos of x equals positive 1. Now from here I like to always draw a sketch of the graph, so I'll draw a sketch of cosine of x. I'll do that down here. And so I know that it starts at 1, goes down to negative 1, and then comes back up to 1 like this. And I'm in radians, so I'll label up the graph in radians like this. So there we go, that's just the first period. That's always what I draw, just between 0 and 2 pi. Now we could use our calculator, but we're just solving cosine of x. There's no transformations happening, and I'm actually only solving it between 0 and 2 pi. So I don't really need my calculator for this, because I could say, well, where does cos of x equal 0? Well, it equals it here at pi over 2. It equals it here at 3 pi over 2. So let's write in those two solutions. So x equals pi over 2 and x equals 3 pi over 2, like this. Now let's solve the other equation on the right. So that's, where does this graph cosine of x equal 1? Well, I can see that it equals 1 here when x equals 0. So let me write that in, x equals 0. And it equals it here when x equals 2 pi. Now if we look at the interval we're solving on, between 0 and 2 pi, we're not actually including either of those two values. And so I'm just going to reject both of these solutions, and I only get two solutions for this question. X equals pi over 2 or x equals 3 pi over 2. Now you could, if you really wanted to, even though it's quite obvious from the picture, check by adding and subtracting the period of the graph to see if there are any additional solutions, but hopefully you can tell quite quickly, well, if I add or subtract 2 pi to this, it's clearly going to take me outside of my interval. And so we're done, and we just get two solutions. Okay, let's look at the second question, where we're asked to solve cos squared of x plus 30 minus 2 times sine of x plus 30 minus 2 equals 0, and we're solving that between 0 and 360 degrees. Now initially this might look quite tricky because we've got this x plus 30 inside the argument of our trig functions, but actually it doesn't make a difference. We'll solve it in the exact same way, and so our first goal is to rewrite it all in terms of sine, cosine or tan. Now I can do this by saying, well, I've got a cos squared here, and so I can use my trig identity sine squared x plus cos squared x is 1, and if I subtract sine squared from both sides, I get that cos squared of x is equal to 1 minus sine squared of x. Now we can still use the trig identity even though there's this x plus 30 inside the argument of the function. All it means is that when I rewrite it, I'm going to rewrite it like this. 1 minus sine squared of x plus 30. So you just keep whatever's in the argument the same. So then this is minus 2 sine of x plus 30 minus 2. I'm going to have to move this over a bit. There we go. Minus 2 equals 0. Now from here I'm going to use substitution to make it look a bit nicer, but again if you're quite confident with solving hidden quadratics you don't have to, but I'm going to say let u equal sine of x plus 30, and so now this equation is going to become 1 minus u squared minus 2 lots of u minus 2 equals 0. And now because I'm just solving a quadratic equation, to make it a bit nicer I'm going to add everything across to the other side, so my coefficient of u squared is now positive. And so this is going to become 0 equals u squared plus 2u. Well, I'm adding across 2 and then I'm subtracting 1, so it's going to be plus 1. And so to factorise this, I'm looking for factors of 1 that sum to give positive 2, and that's just going to be a repeated solution, so that's going to be u plus 1 all squared. And so if u plus 1 all squared equals 0, that must mean u plus 1 equals 0, which gives me u equals negative 1. So remember, we're not solving to find u, we want to find out what x is, so I can now undo this substitution and I get that sine of x plus 30 equals negative 1. So now I'm going to draw out my sketch of the graph like I always do, so let's draw that out, and I'm going to do it between 0 and 360. Remember in this question we're working in degrees, not radians, so 90, 180, 270 and 360. Now, if we take a look at the graph, where does this graph sine of x equal negative 1? Well, it only does that at one point here. So within each period, there's actually only going to be one solution. And so I could use my calculator to do inverse sine of negative 1, but I can actually see it quite clearly just by looking at my sketch. It's when x plus 30 equals 270. So let's write that in. Equals 270 degrees. I'm now going to subtract 30 from both sides, and I get x equals 240 degrees. And I can now, if I want to, add or subtract the period of the graph, which is 360 degrees, and see if there are any other solutions in this period that I'm solving in. But hopefully you can see that, well, if I add or subtract 360, I'll be way outside that range. And so there's only one solution at x equals 240. And the nice thing about these questions is, if you really wanted to, you could put x equals 240 in for x in this original equation, put it all into your calculator and press equals, and if it equals 0, you know you've done it right, which is quite nice. Let's now look at the final example we're going to look at, which is solving 2 sine squared of 2x equals 5 times cos of 2x. And this time we're in radians, we're solving between 0 and pi. So I'm going to do the same thing. I need to get it all in terms of sine, cos or tan. Well, I noticed that there's this sine squared here, and so I could use my trig identity. Sine squared plus cos squared is 1, and minus cos squared from both sides, and I get sine squared of x is equal to 1 minus cos squared of x. And again, it doesn't matter that there's this 2x inside of the argument of the function. I'm just going to use the identity and make sure that instead of writing 1 minus cos squared of x, I do 1 minus cos squared of 2x. So let's do this substitution. Now, we need to watch out because there's also this 2 in front of the function. So it's going to become 2 lots of, and make sure you put brackets around it all, 1 minus cos squared of 2x, close the brackets, equals 5 times cos of 2x. Okay, now you need to be careful of that because a lot of people will just forget about this 2 or just multiply this 1 by 2. You need to put brackets around the whole thing. So now let's expand it all, and we get 2 minus 2 lots of cos squared of 2x equals 5 lots of cos of 2x. Let's put everything onto the same side, and we get 0 equals 2 cos squared 2x plus 5 lots of cos of 2x minus 2, and that equals 0. Again, we've got a hidden quadratic now, so I'm going to use a substitution. I'm going to say let u equal cos of 2x. So I'm now going to rewrite the original equation using this substitution, and I get 2u squared plus 5u minus 2 equals 0. Now, I don't believe this equation is going to factorize, so I could use the quadratic formula or just solve it on my calculator. Doesn't really matter. If I use my calculator, it tells me that u equals minus 5 plus root 41 all over 4, or I get another solution that u equals negative 5 minus root 41 all over 4. Now remember, we're solving to find out what x is, so let's undo the substitution, and I get cos of 2x equals, again, minus 5 plus root 41 over 4, or cos of 2x equals minus 5 minus root 41 over 4. So not very nice numbers here. So let's start off by solving the equation on the left hand side, and like always I'm going to start out by drawing a rough sketch of the graph of cosine. So it goes from 1 down to -1 back up to 1, and we're in radians, so it's pi over 2, pi, 3 pi over 2 and 2 pi, like this. So -5 plus root 41 all over 4, if I convert that to a decimal, it's 0.3507. So it's going to be somewhere around here probably, which means I'm going to get these two solutions here. So let's do inverse cosine of that on our calculator, making sure that we're dealing in radians, not in degrees. And so my calculator tells me that 2x equals, let's do three significant figures, equals 1.21, which I suppose is going to be this solution here. Now remember, using the symmetry of the graph, well, I've gone 1.21 radians to the right of the origin, so to find the other solution I'm going to go to 2 pi and go back 1.21 radians. So I'm just typing in 2 pi minus 1.21, and that gives me that 2x could also equal 5.07 radians as well. Now I've got these two solutions in the initial period, I can divide by 2, and so I get x equals, for this first one, 0.605, and if I divide the other solution by 2, I get x equals 2.54 to three significant figures. Now if we go back to the interval, we're solving between 0 and pi, so pi is, let's say, 3.14, just so it's easier for me to tell if I'm accepting or rejecting a solution. So far I'm accepting both of these solutions, they seem pretty good, but let's just check to see if there are any more, and we do this by adding or subtracting the period of the graph. So we're solving cos of 2x, and what this 2 does is stretch the graph scale factor 1 over 2 parallel to the x-axis, so it makes it half as long. And so the period of the graph was 360 or 2 pi radians, so the new period is half of that, so it's just pi. So I'm going to add and subtract pi to both of these solutions and see if there are any more. But as I'm only solving between 0 and pi, if I add or subtract pi to either of these, hopefully you can see I'll be outside the range of valid solutions. So there's only 2 there. Now let's look at solving this other equation, this one on the right. Well, if you actually look at the number -5 minus root 41 all over 4, as a decimal, that number equals -2.85. And well, cosine of 2x will never output anything more than 1 or less than -1. You can see that if we look at our graph, it goes between 1 and -1. And so there's no solutions for this equation, and so I can just cross it out and we're done. So hopefully this video was useful. If it was, please do go over to my channel where I have loads of other maths tutorials, and you can also go over to my website, which I'll link in the video description, where it's a bit easier to navigate through all the videos I've made. Thanks for watching.